Good afternoon. This is a quick review on Hess's law and combining chemical reactions, as well as using the enthalpy of formation to calculate the enthalpy of the reaction. So you have two questions from the study guide, 27 and 28. Let's get to it. So we first want to find this third equation. We're going to use the first two to calculate the third. The first thing we're going to do is identify and observe which are the reactants and which are the products. So the reactants are on the left and the products are on the right, and if you notice SO2 has a box around it, that's because it's a reactant and a product. When we see that, we know that this whole equation has to flip. Notice that solid sulfur is not in the final equation. So when we see that, we know that eventually they are going to have to cancel each other. But they can't do it yet because they're on the same side of the equal sign. So let's flip the second equation. So I rewrote both equations, and when I flipped the second equation, the enthalpy changes the sign as well. But notice this is only one sulfur and this is two, so we need to multiply the entire equation by 2 so that they can cancel, which means we'll also end up multiplying this by 2. Now, since I multiplied the second equation by 2, I can now cancel 2 sulfurs because they're on the opposite side of the yield sign. And I can also cancel 2 full sulfurs here and leaving just one O2 here. Now I can add both the equations together and also add the enthalpies of each reaction. So I add both the equations together and I get the third equation that I'm looking for. 2SO2 plus O2 yields 2SO3 with the enthalpy of negative 196. That means it's exothermic. And that's it. Thank you. Okay, so that was the 27. Let's do number 28. Let's do enthalpies of formation. So we know that energy is within each molecule, and that's equal to the energy it takes to form that molecule. So by measuring the energy it takes to form the molecule, we can add and mix and match those together using the molar coefficients. So the first thing we want to do is take these here and place them underneath our balanced equation. Now I'm going to multiply by the number of moles in the balanced equation. So it's a 2 here and a 2 here. Next I'm going to add each of those together, keeping track of the negative signs. Those are very, very important and a common cause for mistake. Step 2 is we're going to subtract the products, energy in the products from subtract the products and the reactants. We can do this because enthalpy is a state function, which means it's not path dependent. So this is the initial and the final that matter, not how it gets there. So the energy of the products is negative 2919, and the energy in the reactants is negative 2787.4. A common point of mistake is to add these instead of subtract them. So I put that subtraction sign in red to make sure that when we subtract a negative, it turns positive. When you add a negative, it stays negative. And our final answer, negative 130.6 kilojoules per mole for this reaction. So that's a quick review of these two questions. If you have anything else, come see me during class or after school, and I'll see you tomorrow. Have a good day.